This is Neil Schneider for MTBS-TV at GDC 2019. To my immediate left is William Provancher. I hope I'm pronouncing that properly. He's CEO of Tactical Haptics. Welcome to the program, William.
Thanks for having me.
Now, we've actually connected before, and you've been hard at work at Tactical Haptics for a few years now.
Yeah, very long time.
So for those unfamiliar, what does Tactical Haptics do?
So we're trying to commercialize a new type of touch feedback. It's based on a fundamentally different principle than vibration. What we're doing, in contrast, is taking advantage of mimicking the friction forces you'd feel if you're holding an object like this microphone and then I was trying to pull it away from you. What keeps it from escaping your hand is those friction forces. And we mimic those through the handle of a game controller, and by tracking your hand and responding to it, it creates these wonderful illusions of elasticity and inertia that just shouldn't be possible otherwise.
See, I know that haptics is usually a big challenge. I mean, yes, there's vibration that they try to mimic, add some sensitivity there, but a real challenge with haptics, as I understand it, is there's no firm resistance. You know, if you're pushing against the wall, there's nothing really there to push you back, which is why haptics tends to be a big challenge. Can you talk a little more as to how you overcome that challenge?
Sure. So, using vibration, there really is no real great way to present physical resistance, pushing through things. And so people will present a little accent or an impulse when you make contact with something. And sometimes people will kind of abide or obey the physics rules because of that. But the real way that people have done this in the past is they will have a benchtop device. It's a force feedback arm, and it's presenting real forces to the user, usually through a stylus or a knob or something like this, like the Novin Falcon, for example. But it restricts your motion to that very tiny little workspace, or else if it's got a large workspace, it's either going to be pretty scary and dangerous or very expensive, or both.
Okay, good stuff. Now, maybe you've got a device in your hands. Can you showcase how it works?
Sure. So the way the device works is, so it would normally have a tracker. So here's an example of a device. It's got a location for a Vive tracker on there. I should also just point out at the same time, we have versions that work with the Oculus Touch on there as well, and then we have mounts for Windows MR, mixed reality. The way it works, you can see here on the surface, there are these little plates, and they're actuated, and they can slide back and forth. And when you are holding an object, say my favorite example is a sword, you go to stab your opponent. Normally what happens is if the friction wasn't there, it would just kind of slip through your hand. Well, when you're holding onto it and there's opposition there, the way that the forces from the outside world gets into your hand is through skin. And it turns out that you're 4 or 5 times more sensitive to shear than you are to the normal forces. And in fact, you're hardwired to pay attention to shear forces. I'll give you an example of why that is. So think about, you're holding a glass. Do you really think about, when you're at the bar holding a beer, your grip force the entire time? No, it's very natural. You just hold it. When do you pay attention to your grasp force?
When you drop it.
Yeah, when it's about to slip through your fingers. That slip that is in this tangential direction is aligned with that shear force that we're applying. So you're hardwired to pay attention to the forces that we're doing. So what we do is we track your hand in space. That's the kinesthetic portion of touch. And we give you the dominant portion of the tactile. And with that, your brain just kind of fills in the rest. And when you're in VR and you're getting the sights and the sounds and maybe even the smells, it's a really nice illusion.
Okay, so this is, I take it, you kind of highlighted, this is intended to collaborate with virtual reality. Does it have to? Does it have a use case outside of VR as well?
Yeah, absolutely. So, it's interesting. The first GDC we ever went to was 2013. Ironically, we were right next to the IGF booth again that year. And we were sitting in front of a big laptop, wired controllers in front of there. And so gaming in general, of course, you could just be on every console, especially if you had good tracking, like a Sony Move. But teleoperation is actually one of the very first applications we did. We had an SBIR, a Small Business Innovative Research Grant, with NASA. And the idea was to use this to have a greater level of presence with a teleoperation robot, like Robonaut. So you could have Robonaut go outside rather than an astronaut go outside the space station, and you could kind of feel those interaction forces. You don't need to feel everything on the fingertips, but if you're holding a drill driver, it's good to know, like, did it catch? And these resultant forces. And that's what we're able to go and present with this, because we're mimicking those same friction forces that respond to your actions.
All right, good stuff. Now here we are. We're at Game Developers Conference, so that should give away something. Do you want game developers to support this? What's your ideal goal here?
So right now our focus is, we have been gaming oriented. Location-based entertainment is kind of our current thrust, and the reason is because our initial deployment, we're not at scale. We have some costs associated with what we're doing, and so a good market fit for us are these family entertainment centers. Sometimes it's actually on the side of a movie. The terminology, the lingo is location-based entertainment, and mostly VR-oriented, but they're emerging all over the world. And so those are our first customers, or the first kind of business to consumer that we're trying to go after as a larger market. But we also have a lot of interest from training. Everything from training the maintenance crew, training the nurse who's going and assist a surgeon, or even just surgical training or physical therapy, swing training. There's all these things you can do when you add this nuanced touch information that you can't do when you're just waving your hands around or getting a buzz every once in a while as you swing through the air.
All right, so now I'm taking it's not for end consumers per se, but maybe you'll correct me. What's the going rate for these devices? What are you anticipating?
So we will be opening up pre-sales. We haven't made any official announcements in terms of the dates or anything like that. We anticipate the pricing to be a little over $1,000, probably in around $1,500 for a one-off. And we'll work with people at larger volumes, but it's going to be in this little over $1,000 price point. So it is clearly marketed towards enterprise, and we probably will not limit anybody who wants to order this. So for sure, R&D labs, rich enthusiasts, people who think we'll do something good with it is the people who will prioritize, but we'll just want to know who's out there, who's interested, and get them out there.
Now, these look like sturdy devices. They look like they're designed to last a very long time. Do you have some content creators on board? Have you built some relationships that have started to support these devices?
So our first project was last year. It unfortunately was with IMAX VR, which is no longer kind of in the LBE business, the location-based entertainment business. But we did Justice League VR with them, and we had controllers out at their LA center for 6 months, maintenance-free. They performed very well. We got them back. We've actually gone and done other things with those controllers since. So yes, they're very sturdy. And what we've done since then is do a design for manufacturability to make it just easier to make. And then the other response we got from location-based entertainment centers was, we want something that allows us to have fewer in stock as spares. So the new controller is also symmetrical and can then be differentiated based on left or right, kind of at a later stage.
Now, I've seen the very early versions of these controllers. So congratulations, you've come a long way with them. It's not just the sensations, though. I understand that these controllers interact with one another. There's a magnetic link. Can you elaborate a little more on that?
So the earlier controller I showed you, the one with the purple on it, it was just configured as a core controller plus a Vive tracker bracket. In contrast, these controllers have a touch controller bracket on it, and then have these additional little brackets that add little magnetic sockets, and you'll see a male and a female and a magnet associated with them. So you can configure them to join on the fly in this kind of gamepad steering wheel configuration. This would be like handlebars on a steering wheel, handlebars on a bicycle. This would be like a machine gun. This might be like a bow staff also, or a pole arm. All kinds of things you could do with this.
What's really cool is that when you're doing it in virtual reality form, over here, I mean, they're big devices, right? They're, it's the nature of them to make it work is they got to be a little clunky. That's the nature of it. Yeah. But in virtual reality, it seamlessly goes together, and you've got these, the weaponry or the tools or whatever you need, and you don't know what these things look like. You just know about the sensations and how you're interacting with them. So I congratulate you on that.
Thanks. It's been a lot of work. Actually, one of the other things that didn't quite come up, but I'll point out, which is it's actually something we discovered after we started looking at putting these controllers together. and you used it a number of times in the video, on the demos that you tried, is we actually discovered that by putting these together in a certain way where we have just like this cylindrical socket, you actually can have user input after the fact that creates a really nice user interaction that it kind of goes beyond, like it continues the same kind of analogous configurational ergonomic changes that you're making that change your gameplay, but then goes one step further to say, now like I do my reload like a bolt action rifle like people are kind of used to. So that was like the extra big win, was discovering that we could do this at the same time as adding these different configurations that were going to be so useful in VR gameplay.
Good stuff. Well, congratulations. Thanks so much for joining us.
Yep. Thanks for having me.
This is Neil Schneider for MTBS-TV at GDC 2019. We will, of course, be back with more. Thank you for watching.